Hello, class. This is a wrap-up of problem number 7 from the Chapter 7 sample problems, which we started to talk about during class. This problem goes through how does the variance problem look for us if we have a mix of inputs that are going into a product. So we've got a snack food company that makes snack mixes, and the snack mix that they make, Tempting Trail Mix, contains peanuts, dried cranberries, and chocolate pieces in the following proportions. Their budgeted amounts are 60% or 60 cups per mix, 30 cups of dried cranberries, 10 cups of chocolate pieces, the 60 cups was peanuts. So out of 100 cups, approximately, we calculate out our batch by taking our budgeted price of each input, multiplying it times the quantity for each batch, which gives us a budgeted cost of $150 per batch, and each batch size is 100 cups. So the budgeted cost per batch of 150 multiplied times 100 batches gives us a budgeted cost for 100 batches of $15,000. To calculate the direct materials efficiency variance, as we did during class, we took the actual quantity of inputs used for each product, subtracted from it the budgeted or standard quantity of input allowed for the number of batches, which is 100 batches. So this was the actual cost that they provided us here for 100 batches. And these were the budgeted quantities of inputs that we would have for 100 batches. So 60 cups times 100 is 6,000, 30 cups times 100 is 3,000, 10 cups times 100 batches is 1,000. And then the budgeted prices of inputs, which were provided to us over here. When we calculate those out, it gets us to efficiency variances of 720, which is unfavorable because we actually used more than we budgeted. So unfavorable for peanuts, favorable for cranberries because we used less actually than what was budgeted. And then in terms of chocolate, we used more than budgeted, so that was also unfavorable. Also during class, we did the mix variance, which is how much of that dollar value of efficiency variance is due to the percentage mix. So we took the actual direct materials mix percentage that was used. So here we used 6720, 2625, 1155, total of 10,500 cups. If you take that amount and divide it by the 10,500 cups, 64% was peanuts, 25% was dried cranberries, and 11% was chocolate pieces. So with that, we take our actual percentage mix, subtract from it the budgeted percentage mix that we were provided, and then we multiply that times the actual total quantity of inputs, which was the 10,500 total cups, and then multiply that times the budgeted cost. And that gives us our mix variance, which we calculated during class, which is why I'm kind of hurrying through this a little bit. So we used a higher percentage than estimated. So 420, that calculation ended up being unfavorable because we used more than expected. Here we used less than expected, so that's favorable. And then here we, again, actual was more than budgeted, so again, unfavorable. So just quickly recapping where those numbers came from. Now we're going to talk about the last type of variance, which is the yield variance. To calculate our yield variance here, we're going to take the actual total quantity of inputs used, and we're going to subtract from that the budgeted total quantity of inputs allowed, right? So again, we have an efficiency variance difference going on here. We're going to multiply that times the budgeted direct materials mix percentage, and also times the budgeted dollar cost of the direct materials input. So we're taking the difference in quantity used times the mix percentage and times the price. Okay, so Here we used actual quantity in total of 10,500 total cups. So we used this amount, again, actual total quantity of inputs used. We used that same amount up in our mix variance formula. And then the budgeted total quantity of inputs allowed. So in theory, for 100, we'd have 100 cups per batch. So 100 cups per batch times 100 batches would be the budgeted total we would allow. So 100 times 100, 100 batches times 100 cups per batch gets us to 10,000 budgeted total inputs allowed. So in terms of what we used in total input cups, we're taking the difference there between those two. And then we're taking that times the appropriate mix percentage for each of these. And then times the budgeted price for each of these. So basically what we're doing is a weighted average of the quantity difference that was used in total, okay? So the yield variance here, then we do this math, all right? So we're gonna say 10,500 minus 10,000. All right, let's just do that math here. So that's a $500 difference here. It's gonna be the same for all three of these. So we're gonna take 500 times 0.6 times 1 and 500 times 0.3 times 2 and 500 times 0.1 times 3. So that got us variances of 300, 300 and 150. And those are all three the same direction. So they're going to combine together here, right? And so we've got here, because we used total quantities more than budgeted, all of these are unfavorable. So overall, it's unfavorable. All right, now it's possible that if we had used, so all of these are going to be the same direction, by the way, right? Just because of the way this is formatted, average total quantity minus budgeted total quantity of inputs. So if we are over in our usage in total for these mixes in terms of total quantity of inputs, then we're going to be unfavorable across the board, all right? So that gives us a yield variance of $750 unfavorable here. So ultimately, how do the variances we calculated in that requirement relate to those that are calculated in requirement 2? Well, the total mix variance combines, so the total mix variance is the total yield variance. So the mix variance plus the total yield variance equals the total efficiency variance. So 750 here, unfavorable, and 315 favorable. Gets us, oh, sorry, 750, not 15. Whoops, do my math right. Gets us a difference of 435 because one is going one direction and the other one, which, as we see, ties out to our efficiency variance that we calculated here. There we go. Oops, no, that's not the right one. This one right here. There we go. Total mix variance combines with the total yield variance to equal the total efficiency variance. All right, and then finally here, direct materials variance indicates that the actual product mix uses relatively more of the less expensive ingredients than planned. And then the direct materials yield variance occurs because the total number of inputs needed exceeded the budgeted amount. And then the mix variance may be within expectations, but should be monitored. Since it is favorable, should be monitored since it's favorable. largely due to the use of fewer dried cranberries, which is considered an important element of the product's appeal to customers. The direct materials yield variance is significant enough to be investigated. So that wraps up our last problem for chapter 7.